Yo, what's good? Welcome back to another episode of How to Algebra. Today we're tackling graphing systems of linear inequalities. Imagine shading regions on a graph to find where solutions overlap. This is where the magic happens. We'll break down how to graph each inequality, figure out which side to shade on, and then find the solution set where all the shaded areas intersect. It's all about visualizing the possibilities and locking down the solution. Get your graph paper ready because we're about to make it click. Let's get it. All right. Graphing system of linear inequalities. So the idea is that you graph the line, right? We should all know how to graph a line from Algebra 1. Y equals mx plus b, right? Y equals mx plus b. That's a line. All right. So here's the deal. The equal sign in y equals mx plus b, if it's not an equal sign, right? What if it's one of the four inequalities? Greater than or equal, greater than, less than or equal, or less than, right? If, depending on which of the four symbols it is, then that'll determine the type of line and the side of the line that you're going to shade on. So we're going to shade on one side of the line. Now, the idea, right, is that the reason you're shading on a particular side is that any point that falls on that side is the solution to the inequality. And because it's a system of inequalities, meaning more than one inequality, wherever there's, so you have one line, and we're going to shade on one side of that line. Then you have another line, and you're going to shade on the one side of that line. Where the lines overlap, or where the shaded part overlaps, where the shaded part overlaps, that's going to be the solution that satisfies both inequalities. So watch, let's get some notes real quick. All right, so something to recall from Algebra 1, depending on when you took Algebra 1, but something that is taught is that here we have, so greater than. So greater than is up top, right? As you read from left to right, just like reading a book, from left to right, since we encounter the larger side of the inequality first, it's greater than. Likewise, less than, when you're reading from left to right, if you get the pointy side first, the smaller side, the lesser than side, then it's less than. All right. Something else to note is that when you have less than or equals, greater than or equals, anytime you have the or equals, this is going to give you a solid line. A solid line. And if you have strictly greater than or strictly less than, this is going to give you a dotted line. Right, it's not just a line. It's either solid or it's going to be dotted. All right. Then we're going to have to shade on one side of the line. So the way that it's taught is that when you have, say, y greater than or less than mx plus b, right? Mx plus b could be anything. You shade above the line. Now, will it always be in the form y is greater than or y is less than? No, it will not be. Matter of fact, most of the time it's going to be mixed in, and you're going to have to isolate y and get y by itself. So typically the technique is that you're going to leave y on the left-hand side and move everything to the right-hand side to isolate y, right? So if y is less than or equals something, you're going to go below. But you'll see this in a minute. But here, this is literally rule of thumb right here. So if you can burn this into your memory banks, you should be you should be able to graph this thing, or graph it accordingly. So this is really all you need to know. So greater than or equal, greater than, you're going to go above, we're going to shade above, less than or equal, less than, we're going to shade below. And then whether it's a solid or a dotted line. All right, let's just see some examples. All right, example 1. We're going to graph the system of inequalities. All right, so remember, as mentioned, recall from Algebra 1 that it must be in y equals mx plus b form, right? Y has to be isolated, and everything else needs to be typically on the right. So y by itself, that's the important key, y by itself, because that's the only way to graph it. Because right now, just looking at this, 5x minus 2y less than or equal to -4, it's not clear on what the y-intercept is or what the slope is. So we have to put it in a form where it's easily identifiable. So what we're going to do is start moving everything to the right algebraically. So I want to solve for y. I want y to be by itself. So I'm not going to touch the y at all. So I'm going to subtract 5x from both sides. So we're left with -2y less than or equal -5x. So you always want to write the x term first, minus 4. All right. We're going to isolate the y by dividing everything by -2. Now notice how I'm dividing each term by -2. All right, here we have an important note. So when we divide or multiply by a negative, we have to flip the sign. When we divide or multiply, let's do an x, right? X means multiply, right? Times by a negative, we flip the sign. Okay. So that means -2's cancel. We have y. And we had less than or equal. So we need to flip that to greater than or equal. Negative divided by negative is a positive. So positive 5 over 2 x. Again, -4 divided by -2 is positive. 4 divided by 2 is 2. All right, so now y is greater than or equal to 5/2 x plus 2. So when we look at this, we see, okay, it's solid for sure. It's solid. And we're going to shade above because it's greater than or equal. So solid, shade above. All right, above what? Above the line that goes through the y-intercept should be highly identifiable right now, +2. And then the slope is going to be up 5 over 2. So up 5 over 2. And it's solid. And we want to shade above. Okay. Second line. Y is less than -2/3 x. So right away, y is already by itself. So we don't have to do anything algebraically. We just have to interpret correctly. So this is strictly less than. So this is going to be dotted. And we're going to shade below. Dotted and below. So the question is, where does it cross the y-axis? Well, right, there's no, the y-intercept, it's there, it's just invisible. It's +0. It crosses at 0. Y equals 0, that is. And down 3, or correction, down 2 to the right 3. So down 2 to the right 3. And we said it was dotted. And we want to shade below. Below. And now you can see the overlapping part. So everything that is overlapping, including any solid lines, and excluding any dotted lines, but the overlapping part, that is definitely where the solutions lie. All right, using the graph, are these points of solution and why? So let's see. So we'll go -3, 2. So -3, 2. I'll do it in yellow. So -3, 2. Okay, this is on the dotted line. Therefore, it is not a solution. So we'll say no. And it's because it's on the dotted line. However, it's in the red, so it'll definitely satisfy the red equation, or the equation to the left, but it will not satisfy the right equation. Therefore, it's not satisfying. It's not a solution to both of them. Okay, -4, 0. So -4, 0 is definitely in the solution set, right? And it's because it's in both shaded areas. Both shaded areas. It is a solution. All right, last but not least, -2, -3. So -2, -3. All right, so this is on the solid line. It's on the solid line, and it's in the blue, right? It's in both. This is definitely a yes. And it's in both shaded areas. Right, it's on the line of 1, which counts as being in the shaded area of the red, and it's in the shaded area of the blue. Tell whether the order pair is a solution algebraically, not using the graph. Okay, so here for A, B, and C, we graphed them, and then we said, all right, are they apart? Are they in the graph or are they not? So now, if we didn't have a graph, algebraically, how do we figure this out? Well, we have to take both equations. So now we forget about the graph for a second, and we just look and see. All right, so -3, 2. Right, this is my x, this is my y. So if we take x and y and plug them in to their respective variables and just analyze the equation. So 2 less than 5/2 times -3 plus 2. This is going to be 2 greater than or equal -15/2, right? Because -3 is really -3/1, and top times top, bottom times bottom, plus 2. Okay, here is where we have to simplify on the right. So we need a common denominator. Technically, do we? Let's see. 15 divided by 2, we know that's what? 7.5. So this is -7.5 plus 2 will give us -5.5. And we say, okay, is 2 greater than or equal to -5.5? Yes, that's true. That is true. It is greater than. 2 is definitely greater than. 2 is greater than any negative number. All right, on the right-hand side, plugging in again the respective variables. 2 less than -2/3 times negative 3. All right, on the right, negative times negative is going to be a positive number. And then the 3's are going to cancel. So the 3's are going to cancel. Let's just say for the sake of argument, you didn't know that they were going to cancel. So then I would do negative times negative is a positive. Top times top is 6. Bottom times bottom is 3. But 6 over 3 reduces to 2. And now we say, okay, is 2 less than 2? No, it's not. Not at all. It's exactly 2. So this is false. So to answer the question, to tell whether negative 3, 2 is a solution, it is not a solution. Because when I plug in the point into both equations, they both must be true for this to be a solution. If one of them is false after you plug in to the equation, then it's not. Like right away, you know that it's not. All right, let's try. I mean, feel free to pause the video and see if you can work this out on your own. Negative 4 is 0. So we're going to say 0 using the same equations, using the exact same equations. Greater than or equal 5/2 times negative 4 plus 2 and 0 less than negative 2/3 negative 4. All right. So solving the left one, we got 0 greater than or equals, this would be negative 20 over 2 plus 2. So negative 20 over 2, that reduces to negative 10 plus 2. Negative 10 plus 2 is negative 8. So 0 greater than or equal to negative 8. Is that true? Is 0 greater than or equal? 0 is bigger. It's bigger than any negative number. So this is true because 0 is greater than negative 8. All right, on the right. If this is true, negative 4 comma 0 is a solution. If this is false, negative 4 comma 0 is not a solution. So this is going to be 0 is less than, so a negative times a negative, that's a positive. Positive what? 2 times 4 is 8 over 3. So is 0 less than positive 8/3? Yes, it is. 0 is less than any positive number. This is true. Therefore, negative 4 comma 0 is a solution to both equations. It is a solution. All right. So here's some more practice on graphing. Maybe you got it, maybe you don't. Let's just roll with it. So I'm looking at the two inequalities. So the left equality, I got to get y by itself. Right away, you got to start getting y typically on the left. So I'm going to subtract 2x from both sides. And I always write it in a way that looks like y equals mx plus b. So I always write the x term first. Divide both sides by 3. So y is less than negative 2/3 x plus 2. Do I want to graph it now? So let's see. Crosses at 2. Let's do it in red. So it crosses at 2. All right, this is going to be a dotted line. It's dotted. And we're going to shade below. So dotted, shade below. Right, because it's less than, strictly less than. All right, so I'm going to go down 2 to the right 3. So from the y-intercept, I'm going down 2 and to the right 3. And it's dotted. Okay, looking at the right equation, it's already y is already by itself. That's nice. So we're going to cross at positive 4. It is greater than or equal, so this is a solid line. And we're going to shade above, right, because it's greater than. So I'm going to go down 2, and again to the right 3. That's crazy. So down 2 and to the right 3. Down 2 and to the right 3. And it's solid. And we're shading above. For the other one, I forgot to shade below. I'll do that right now. So we're shading below. All right. So then when we look and see, like, all right, where do they overlap? So if you notice, there is this gap in between. Right, there's this gap that separates the blue and the red. Right, it separates the blue. So when this happens, there is no solution. So no solution. Right, because there is no overlap. There's no overlap. Sounds interesting. Oh, look, we got 3 on this next one. Example number 3. We have 3. Haha. So let's do it in red. Y equals, or y is less than or equal to 3. So first off, this is a solid line, right? Because it's or equals, and we're going to shade below. Not only that, but if you haven't figured it out yet, y equals or y less than or y greater than, y equals the number is a horizontal line, right? This is going to be a horizontal line. So at y equals 3, we have a solid line and we shade below. All right, x is greater than 2. X is greater than 2. So this is a dotted line. We're going to shade above because it's greater than. And this is a vertical line. So x equals a number, x greater than a number, x less than a number. This is a vertical line through -2. X equals -2. So it's dotted. So here we have to shade above. So now let's think about that, right? Because it's a vertical line, there is no above. So we want to shade on the side that makes sense. I want x greater than -2. So I need something bigger than -2. Therefore, I'm going to go to the right of the line because anything to the right of -2 is going to be bigger than -2. So it's all of this to the right. So right now, the solution to just these two is that bottom right quadrant, right? Like on the red line and below, and then to the right of the dotted line. So everything in this bottom right overlapping part satisfies both of these. So now we have a third equation. I'll use green. So y is greater than x. All right, this is definitely a dotted line. It's definitely above. So if you think about what y equals x is a 45-degree angle line, right? It's through the origin, 2, 2, 4, 4, like whatever y is, x is. And we want above. All right, so this is getting messy real quick. All right, so there is, if you can see through the madness, here, I will shape it out for you in black. All right, there's a section here. So this solid line, this dotted line, and this dotted line, and everything in the middle. So the solution to all three of these is in this black triangle that you see here. So as long as it's on that solid black line, any point that's on the solid black line or in the solid black area, excluding the dotted line, right? If for instance 0, 0, right? 0, 0 does not satisfy this thing at all. It's right on the dotted line. So there's no solution. Well, I take that back. There is a solution, and it's in the area that I'm showing you here. All right, that's the solution. There's really no way to write it, but it's where all three overlap. All three overlap. Let's try another one. Hopefully this one is better. All right. Y greater than. So this is going to be a dotted line. We're going to shade above. Okay, so this is going to be cross at -3, right? Y-intercept at -3, up 2 over 1, up 2 over 1, and it's dotted. And we shade above. All right, x greater than 7. So it's a vertical line through -7. It's dotted. And we're going to shade above, or technically to the right, because anything to the right is greater than, right? Anything to the right is greater than. So -7, dotted, and we want to the right. So now it's everything to the right. It's everything to the right. Try not to lose sight of the dotted and the redness. Okay. Last but not least, y less than 8. So again, dotted. And we're going to go below. Below 8. So it's dotted and below 8. So dotted line through 8. And we want below. Okay. So let's see if I can help you out. Hopefully you can already see it. Hopefully you can already see it. I'll do it in black so you can see it. So what area satisfies all three? So where is it overlapping? It's overlapping. Showing you now. Where these are all dotted. So any point that is in this black area here. Right, this black area is where it overlaps. If you're doing this in pencil, you can shade lightly one direction, and then where it overlaps, you can make it darker. That's a way of doing it. So here are the solutions. So recapping. What's important? Knowing how to graph. Right, knowing how to graph. Y equals mx plus b, that's crucial. Like, you spend a whole year talking about it. So you have to be able to look at it and know, all right, the line crosses at the y-intercept and has a slope of whatever. And you just have to be able to graph a line. Right? Technically, what we're doing is you're graphing multiple lines, and then the line is either dotted or shaded, dotted or solid rather, and then you're shading on one side of the line, either above or below. So regardless of what equation you're given, right, you should be able to know how to algebraically manipulate an equation to get y by itself. Once y is by itself, then you can do a little quick analysis and figure out, okay, is the line solid, dotted? Do I shade above or below? And then you do that. And then you can see, once you've done it, that there is an overlap. Or there won't be any overlapping parts. You know, if there's no overlapping parts, then there's no solution. That one's easy. But if they do overlap, and most of the time they will, you have to be able to identify the area that is overlapping. And be sure that you're paying attention to where the line is solid and where the line is dotted. All right, hopefully this helps someone. I'll catch you guys in the next video.